Okay, good morning, all dear students. Today, actually, so we have to conduct lab sessions. Along with that, one more topic is remaining from the unit number 3, that is directives. So before going to this lab session, I will take 10 to 15 minutes for one more topic. So as per your syllabus, see, dear students, all of you, am I audible? The screen is visible to you? Hello.
Yes, sir.
Yes, sir.
Okay. Okay. Thank you. So, good morning, one and all. So, dear students, this is syllabus of your microprocessor. Microprocessor subject की syllabus है ये. So, in this third unit, yesterday we have to complete it. That 8086 instruction sets. All the 8086 instructions we covered yesterday. And one student asking me a question, that is again repetition of uh, decimal adjust addition and ASCII adjust additions. So who are the interest if you are not completely understood? So for them today I have to make a schedule at 6 o'clock. So in the 6 o'clock I'll send you one link. To the link you have to join 9. One more time I will explain you in detail. Okay, because today is a lab session, that's what I am not taking. So at the evening 6 o'clock all of you join. I will explain one more time all the decimal adjust instructions and ASCII adjust instructions today at 6 p.m. without fail. Okay. So why this? I have to complete it from the unit number 3. Assembly instruction format we have to complete it, and we completed all the instruction sets of 8086. We completed all the 8086 instruction sets. So only one topic is remaining, very small topic, that is directives. Directives, one topic is remaining. So now I will cover this directives topic within 10 to 15 minutes, and I will go for lab session. Okay. So today we will do one more program in the lab session. That is addition we did, and same 16-bit subtraction we will do. We will tell you how to do it. Okay. So before that, I have to cover this topic, directives from the unit number 3. Directives from the unit number 3. Okay. So uh, now I will go to this slide. See, I have to make a one complete slide for assembler directives. These are the directives from the unit number uh, 3. So some directives we have to use it as along with TASM and assembler languages. Some directives we have to use it. So those are nothing but assume. So as in the program, you used this word assume. Assume means what? Just you have to say to the compiler, this is meaning of what purpose we have to use it in the programming concept, that microprocessor programming concept. So that is assume. So in that we have to use db. Db is defined by ds is data segment, that is different, but just some naming conventions we have to use it here. That is db. Db is nothing but defined by dd is nothing but defined the double word, and dq is nothing but defined word, quad word, and dt is nothing but defined 10 bytes. T in the sense 10 bytes, and dw is nothing but defined word. So dw you used this directives, why, right? So that is a dw, that value in the first program we have to use it. So these all are we call it as directives. So one by one we will look into that. This one. So first one, अभी पहला मैं assume लेता हूँ. What is assume? How it is useful in the program. So for example here, assume directive. The assume directive is used to tell the assembler, that is the name of the logical segment should be used for a specified segment. Logical segment should be used for a specified segment. In the 8086 works directly with only 4 physical segments. What are 4 physical segments? That is code segment, data segment, stack segment, and extra segment. So these are the 4 physical segments are used in the 8086. Along with that, some other directives also we have to use. For that purpose we are using assume. For that we have to using assume. So here, for example, how we have to use it in the program, assume cs code. So assume cs code, all of you use it in the first program, right? In the lab session. Assume ds also you have to use the ds data, and assume cs code. The assume cs code is what? This is tells the assembler that the logical segment named code, that's the logical segment named code, contains the instruction statements, for the program, and should be treated as a code segment. Very important, all of you have to use it in the programming concept. So this is lab session also. In the lab sessions only we have to use all the directives. First directives in the first line all of you have used. अभी हम लास्ट टाइम प्रोग्राम एग्जीक्यूट किए थे, वो प्रोग्राम में पहला लाइन आप assume cs code and ds data you used, right? So why we have to use it? Because that is the directive. Cs code means what? This tells the assembler, we have to tell the assembler, that is the logical segment named code. This code contains the instruction statements for the program and should be treated as code segment. Should be treated as code segment. In the second, one more directives we have to use assume ds data, that is for data segment. So this tells the assembler that for any instruction which refers to a data in the data segment. Code is for code segment, and this data is for to refer to a data segment. That data will be found in the logical segment data. Okay. So for that purpose, in the directives we have to use assume is a directives, and that CS is nothing but a code segment which is used for the code purpose, and DS is a data segment which is to declare the data information we have to use. So next one, as per the list, DB. Next one is DB is nothing but define a byte. So for define a byte, we have to use DB. So in the last program, all of we are used DW. DW is comes here. DW in the sense what? Data word. So this DB is nothing but it is used to declare a byte type variable. Byte type variable. If we want to declare in a uh, assembler language, that time we have to use DB. DB in the sense data byte variable R to store the byte in the memory locations. For example, price. If we have to declare a price or any rate, we have to use the DB. That is the bytes in the bytes. So it may be a 49 value, it may be a 98 value, and it may be a 29 value of hexadecimals. To declare these kind of byte value, we have to use DB directives. That is, declare an array of 3 bytes named as a price and initialize. So for initialize the price value, we have to use data bytes. So in another name, we have to use to declare an array of 6 bytes and initialize with the ASCII code. So this is the ASCII code. For declaration of ASCII code also, we have to use the directives DB, data bytes. Same way for the temp DB, also we have to use it if the 100 duplicates values we are using, maybe 100 or more than 100 values we are going to be used. Okay, one question. So one student is messaged me that okay, what is message? So please send this topic PPT on the group. Okay. Yes, fine, dear students. Okay, okay, fine. Yeah. Uh, okay, this one I'll go to. Okay. Before this, I will share this PPT to all of you. Just a minute. Okay, after opening, I will explain. Okay, I will share you, no doubt. Yeah, fine. So here, in the temp, also you have to use it for the duplication of more than if the same values of one value more than many times. That time also we have to use DB data byte, that is set 100 bytes of a storage in the memory and give it to the name of temp. But leave the 100 bytes uninitialized. That is because same name is going to be given, but that one we are used for duplicates. So in that time also we have to use the DB directives. So next one, DW, as per the list, DW at the last. DW we are going to be used. So here, okay, it takes a time to open the WhatsApp. Fine. In the microprocessor group. Okay, that is documentations. So in that, Just a second, I will transfer it. Okay, this PPT I send to you now. Please, all of you go through it as along with my teaching. So it maybe takes 1 or 2 minutes because so many slides are there in this. Just it takes 1 or 2 minutes. Okay, now we will go through this explanation. So now I will go to the data word DW. So DW is already one example you used, that is this data word directly is used to define a variable of the type word or to reserve storage location of the type word in the memory. So for the first example, we have to use it first to storage location of a variable in DW, right? That is data W. Data word directive is used for storage the location of uh, type word and in the memory, or we have to use it for a variable of type word to reserve the storage. This purpose we are using a DW. So please all of you take this. It is twice. Only one is. Okay. So all of you open along with me the slides. Right. So in that, for example, we have to use the one of the variable multiplier, that DW, or any of the variable ABCD also you have to take with the 437 AH hexadecimal value. You have to use it in such a manner of DW data word. So for that example also you have to go it. So next one more assembler directives we have to use the end. So end data segment and end code segment, end start. For that purpose, we have to using these directives. What is this directive end? The meaning of end directive is placed after the last statement of a program to tell the assembler that this is the end of this program. End means this is the end of this program. That may be a end of data segment, or maybe a end of code segment, or it may be a end of start. So the assembler will ignore any statement after an end directive. Very important. The assembler will ignore any statement after an end directive. So the carriage return is required after the end directives. For that, the console is going to be used for to display the output after the end. So end is used for what? To end the program model. Program model. What are the models? There, those are the thing. But data segment is a one model. Data code is a code segment is another model. All those segments we call it as a one model. So to end each segments, we have to use the end directives. After that, end p also sometimes we have to use it. So end p directives is used to use it along with the name of the procedure to indicate that end of the procedure. If any procedure we have to use it. So in the previous example at the lab sessions we didn't use end p because we didn't use any procedures. So just we used end. You remember that. So here end p is for end procedure. End of a procedure to the assembler purpose we are going to be used end p. And the next, for example, square number for that is pros are you have to use it in this. It start the procedure. Pros means procedure. The mnemonics is pros procedure. Some steps of the find square root of a number. For those kind of things, we have to use end p. We have to use end p for the square number, for the cubic number, and for the square number end p. Here it is the end of the procedure. It's the starting point, and this is the ending point. That is the end p. It's a starting point, procedure, and it is an end point. For that, we have to use end p. End p in the sense what? End procedure. End procedure. It's a starting with procedure and end with the end procedure. So here that is end is used, and p is used, and s. uh, these are the some points you are going to use it. So here that equate, just one more 1 second. Okay, fine. So end is used for to end the program, or end the module, or end the segments, maybe a data segment or a code segment. And end p is used for to end the procedure. If any kind of procedure you are used, for example, square number, cubic number, metric numbers, for that you are going to be end the procedure. At the end of the procedure, use end p. And end s, that end s is used for to end the segments, to end the segments, different four types of segments. That segment is you ending purpose, we have to use it end s. And equate, eq you used for to this directive is used for to equate the two numbers, to equate the two numbers we have to use. And even align in the even memory addresses. So in the even memory addresses, more number of aligned numbers are there. To do the alignment in the memory, to do the alignment of even numbers in the memory, we have to use the even directives. Otherwise, by default, odd directives we have to use it. Okay, even directives and odd directives. One more, that is extern. This extern is used for extra segments. That extern, some more extra segments purpose, we are using this extern. Here I have to mention that I will type and I will give you in the slide. So in that again we have to use it for ends. That ends is nothing but end segment. So in the data segment, after that data ends, you are using it ends data, ends code. So for that, to ends the segments, we have to use it ends. That is ends the directive is used with the name of segment to indicate the end of this logic segments. For example, code segment, you have to started with the code segment with the sum of the code, and you have to ends with code. That is code ends end of the segment. In the program, you have to compare with your lab first program, whatever you practice. That is code segment is started here, and that code segment is ends. That is end segment. ENDS, end segment. So equate, how this equate is used? If any factor with the equate, one of the number you have to going to be do the equate, and for that purpose you have to use the equate directives. There is a factor, one factor variable we are going to be equate with the 03 hexadecimal value. That time we are going to use the equate directives. This equate directive is used to give the name of same value, to equate the name of same value, or to a symbol each time the assembler finds the name of the program. So that will be replace the name with the value or a symbol you given to the name. So for that, 03 is equating to a factor. That time we have to use the equate directives. So, and in the factor, add AL with the factor. So AL is what? That's the accumulator. That accumulator value is going to be add with this equate of 3 value. Add with this equate of 3 value. For that purpose, we are using equate directives. So next one is even directives. In the even directives, it is used with to in the 8086 assembler, that is used with two bus cycles. Whenever you are going to use a bus cycles, maybe address bus or a data bus or a control bus, the word starts with an odd address, the 8086 will take two buses to get the data. In that time, you have to use it either it is a given address modes or odd address modes. So if it is given address modes, to manipulate the memory locations, for that we are going to even. By default it is odd. That's what we are not use the odd directives. So next one is for the uh, so here and some more directives we have to use it, that is group. Group is used for the group of related statements. Label we are used, and name we are used, offset we are used, and originate. These five directives we are used. So those are nothing but, so first one is group. In that group, uh, it includes it the group directive is used to group the logical segments named after the directives into the logical group. So if the same group of instructions are comes, maybe a logical instruction is a one group, arithmetic instruction is one more group, interrupt instructions and data word instructions. So different group of instructions we have to use the single word, that is a group directives. And one more, we use the include. If we want to include any other instructions from the other group to a particular group, that time we are going to be used this include. So this include directive is used to insert a block of source code from the named file into the current source module. Block of, that is block of source code into the current file, including into the current file. That one we have to use the include directives. So after that, some proc is there, and ptr pointer is there. That procedure, this procedure ends, right? Ends p. Procedure is started and ends p, that ends the procedure. So ptr public you used, segment you used, short you used, type you used. So now procedure is for, the procedure directive is used to identify the start of the procedure. The term near for is used to specify the procedure. So in the previous also you studied that, you saw that it is square number procedure. So here smart procedure for value, and that smart is going to be ends with the end p, end procedure. So this is nothing but procedure, this is nothing but end procedure. For that purpose we are using a procedure directives. So next one ptr, that ptr is nothing but pointer purpose we have to use it. So this pointer operator is used to assign the specific type of variable or to a label. So for example, if in inc is there, that is increment, right? Inc is means increment instruction. So inc bx in the sense what? This bx register value is going to be incremented by 1. That is the instruction of inc. So this instruction will not know whether the increment of the byte pointed to a bx register or a word pointed by a bx. Either it may be a byte or a word pointed by a bx, it is going to be incremented. So that time we have to need an address of particular register for the incrementation. So increment byte ptr bx. That ptr is nothing but what? It's a pointer to incremented. Increment the byte pointed to the bx register. What is the meaning of inc increment byte pointer bx? Means that increment the byte pointed to a particular bx value, whatever specified here. So this pointer operate can also be used to override the declared type of variable if we want to access the byte in an array, that may be a words or data words or db. dw is in the sense what? Data words, and db is in the sense what? Data bytes. So for the dw, this one you saw that last we have to use it in this examples, addition of two 16-bit numbers. So this is for uh, PTR. So next one, that is public. Public is used for what? If that instruction or a data we have to access anyway, that time we are going to use the public directives. Once we use the public directives, anyone they can access that data. So the public directive is used to instruct the assembler that specified name or a label with a accessed from the other modelings. Other model means what? Those are segments. For example, if public we have to use it as a directives, that is divisor or dividend. So for going to divide the any two numbers by dividend, so one is divisor and one more is dividend. So that maybe a make it as a public. So divisor and the dividend both we have to access by publicly anyone. that purpose we have to use the public directives. So next one, that is type. So type is used for what? For the cast type. Cast means variable. We have to use it for one form to the another form. So this type operator instructs the assembler to the determine the type of variable. Type of variable means, so in C languages or C++ languages, you have to use the integer data types, floating point data types, double, long, string, char, like that, right? So if you have to convert one data type to the another data type, that one you have to say typecast. That one you have to say typecast in C or C++ programming. But in the microprocessor, that one we have to just to say type. That is nothing but the operator instructs the assembler to determine the type of variable, and that determines the number of bytes specified to that variable. So for example, that byte type variable is converted into assembler will give a value of one. There is a one value, you have to convert it into any other, either it may be a byte or it may be a word. Word to byte or byte to word you have to convert. That time we have to use the type directives. So next one, this is one example how we are going to be use the type. Type in the sense what? BX. There is addition of BX register with the type word. With the type word in the sense what? Word is going to be do the type cost means convert it into byte, and you are going to be add with the BX register. That is the meaning. So these all are directives as per your third unit. And at the last, some DOS functions are there in the microprocessor. For the function call purpose, we have to use the DOS functions. What is DOS? DOS is nothing but a disk operating system. What is dot? So whatever you are going to be type a command, so that DOS prompt commands. So is nothing but disk operating system. So in that, these are the some specific notations in the microprocessor, that is AH0001020809 A0A and 21. These are the DOS function instructions. We call these 6 to 7 instructions, we call it as DOS instructions. So these are the particular purpose. The inventors, the microprocessor that awesome or inventors only, they have to fix it with the tool that is AH00H value means, that is particular meaning, particular specific purpose we have to use to terminate a program. To terminate a program, we use 00H. To read the keyboard value, we use 01 hexadecimal, and to write the standard output to the device, we have to use the 02H, and to read a standard input without any echo, that time we have to use the 08 hexadecimal value with the accumulator value. See what is A? A is a A register, or generally we have to say accumulator with the higher nibble, with the higher bits. H is in the sense higher bit. So accumulator with the higher bits. That purpose we have to use this DOS functions, and this H09 display purpose we have to use it. Either it may be a display string or a character string. Display purpose we have to use this notation, and AH0 AH is used for buffered keyword input. So while going to be buffer in a system, that time we have to use this AH0AH. And then the last one we have to use it int 21H or int 3H or int 1H. So these are for call DOS functions. So all these are going to be called above instructions by this DOS function. So this is all about and directives. Very simple. Just that 10 to 15 directives are there. You have to go through one by one. Clear that presentation I have to prepare. I will share it also. Please, all of you go through it. So this is all about third digit of microprocessor. So by today's this lecture, I'll say I have to completed all third unit concept, but only one student is asking about not too much clear in decimal adjust instructions and ASCII adjust instructions. For that, today at 6 o'clock, I will schedule. Please, all of you join. Whoever has have a doubts or whoever not cleared this concept, so please, all of you join at that 6 o'clock today evening. Okay. So okay, this is all about your third unit. So please, is there any questions? See, I'll give you 5 more minutes. Please go through this all the slides, and if any doubts, please ask me in this assembler directives. Yeah, please. Any doubts in the assembler directives? Ask me.
Hello, sir.
Yeah.
So we didn't know that 11 o'clock you were going to attend the lecture. So can you repeat it in short, whatever you had taken in half hour?
This directives topic.
Yes, sir.
Okay. Are you joined late?
Yes, sir. I didn't know, sir. There is 11 o'clock lecture. Ma'am also don't told her.
No. So actually, why should we have to tell every time? Because this timetable is with you, no? The madam has
No,
shared.
sir. No. Sir, actually today's time is 9:30 to 11:30 first lecture. But due to some office work, ma'am conducted up to 10:30.
Yes, 10:30. But as per timetable, Thursday is only a lab sessions. As per timetable, Thursday is only a lab session. So first lecture that lab session is 9 to so 9:30 to 11, and the second lab session is 11 to 12:30. It is there the timetable only. So okay, no problem. Anyhow, no problem. For the explanation, I will do. I again I will repeat it. No problem. But all of you must and should follow the timetable. Okay. Apart from timetable, we will not do anything. If we will go apart from the timetable, previous to that, we will intimate you. Definitely, will intimate you because this timetable is already saved. I think in the November first date. You check it in the group. It is there. This timetable. So and you don't confuse with all days are same only except Thursday. Remaining all days are having 9:30 to 11 that 11:30 and 12 to 15 onwards they will see. But only Thursday timetable is made for lab session. So each lab session we have to conduct only 1.5 hours for the lab session. 1.5 hours. That's what it is there. Clearly, we have to mention in that timetable. Please, I request you, all of you go through the timetable. Okay. So no doubt, no worry. Again, I will explain you. Please, one more time, all of you have to listen. So today's I am going to be explained as per your syllabus. This is a directive topic. I have to explain today directives topic. So what is directives? Directives are nothing but the name itself it indicates directions. Directions, whatever we have to give a directions to someone to do particular task or to do particular function or work, that is nothing but what we call directives. So same directives we have to use it in the microprocessor. So minimum 10 to 15 directives are there for the specific purpose we have to use it in the microprocessor. So what are those directives? There is a one assume is a one directive, and db is a one directive, dd, dq, dt, dw. This meaning I have to given here only. So assume means what? Assume is a one direct. The name assume, the directive assume we used in the microprocessor, it means that something we have to tell to the assembler, 8086 assembler, we have to tell in such a way that, oh, this is, you have to do the assumption. What we are going to tell to the assembler, 8086 assembler, you are going to be assumed. If we have to declare db, you are going to be assumed for this particular purpose. For example, in the first lab session program, we used the word assume. DS is nothing but data and CS is nothing but code. So that program also I'll show you in this. So this is the first program, right? This one all of you are executed. Yeah, this is the first program. Here what we used, that is assume, right? So all of you clearly visible this my screen.
Yes, sir.
Yes, sir.
Okay, so here in the first line, I have to use the word assume. Everyone you use it, right? So this is the assume is the thing, but what? It is a one of the directives. So the name of this directive is assume. For what purpose we are using? We have to give the direction to the assembler wherever we are using CS is nothing but it's a code segment. CS is nothing but it is a code segment. Normally we say code. So assume uh, uh, that assembler, you have to assume CS means that is a code segment and DS means that's a data segment, because in our program we have to use data segment and code segment. Only two segments we have to use it. For that purpose, we have to tell to the direct assembler, we have to give the direction to the assembler. CS means code and DS means data. This is the first directives, assume. For that purpose, we are using this directives. So second directives is nothing but DB. DB is used for, so here in the same program again we have to use one more DW. This is DW. So only DW I use it because I need to use the memory location of values. Memory location of values. So DW in the sense what? Data word. This is a data word we have to use it. This is the one directives as per our list. DW we use it in the program. That is nothing but defined word. Or defined word we have to use the DW, and a defined byte we have to use the DB. So these later on it will comes in the programs. That time again I will tell you. So DB in the sense data byte. DD is in the sense double word, that is double word. DW is single word. DD is double word. DQ is quad word, and DT is 10 bytes. It is a 10 bytes. This is a specific purpose we have to use it in the programming. This one we say directives. Assume is a one directives. DB, they define the byte, define the double word, define the quad word, define the 10 bytes, and define the word purpose we have to use it in the program. So whenever just you have to remember that these are the directives. Whenever we have to start a program, I will explain all those whenever it is needful. So one already I used it, that is DW I used it in the first program, as well as assume also I have to use it in the first program. So these I think you have to understood. Remaining whenever this concept is comes in the program, that time again I will explain you. Okay, in the programming concept. So next one, that one only I have to give an example, assume directives. So what it will says, the directive is used to tell the assembler, that is the name of logical segment should be used for specific segment. So in that 8086 it works directly with the four physical segments. What are those four physical segment? Code segment CS, data segment DS, and stack segment CS, and last one extra segments. Along with that we have to use this assume. So this is for the explanation, just you go through it. Assume CS code and assume DS data, or in single line assume CS code comma DS data also you have to use it. So next one is used for DB. It is for define byte. So how to define byte? If I have to declare a price value, that time we have to use the DB directives. So in the C and C++, you have to say variables. Here you have to say directives. Okay. So these different naming conventions you have to use with the double, double bytes, defined bytes. Sorry, defined bytes. And same here you have to use it for DW, defined word, and end is also you have to use it in the program. So I'll show you that. So here That end we have to use, at the last. At the last, end is used. End is used for what? To end this module, or to end this program, or to end this particular segment. So end we have to use it for what? To end the entire module or entire program or entire segment. So once we have to use the end means that is end of that point to a particular concept, end of that point. So that purpose we are going to use this end. And one more is end p. If we are going to use any procedures also comes in later on, next more units, that time I will explain you. So any procedure comes, once you have to started with the procedure, compulsory at the last you are going to be end that procedure. So that is end p means end procedure. If you are using the procedure, that time this directive you have to use it to close that procedure end p. So next one, again these are the some more directives, that is end p, end s. End s is used for end segments and for equating two values from the different registers. That time these directives we have to use it. And e1 is used for the e1 memory address purpose, we have to use it for the alignment of e1 memory address. And for by default odd is there. By default odd you have to use it. Only for the alignment of even memory addresses you are going to be use the even directive. And extern also you have to use it for the extra that extra segments. With the extra segments, some more extra values you have to use it, some more extra new values. EXTRN means extra new values you are going to be used. That time you have to use this extern. So next one, that ends p. This ends with the segments. So here in the program again I'll show you. So this is, you see, here you have to use a data segment and data ends. So data ends, here you are using ends, but at the end of the program you are using only end, end. But after each segment you are using ends. Ends in the sense what? That is end segment. So yes comes means that is a segment, end segment. So in the data segment, you are going to be close the data segment. That time you are using ends, end segment, data end segment. So here also you have to use the code segment. That time also you are using code ends. Ends in the sense what? Code end segment. At the last you are using end. End is the last point of the any program or any module. So for that purpose you are going to be use and. So and the equate you are going to be used for the equating one values to a particular register. And even also you have to use it for to even alignment of even memory address purpose. If there is no even memory, then by default you have to use the odd, no problem. And that segments, data segments also you have to use it. So here some sales db duplication purpose you use it. And you got duplicate values, db already you know, that is double bytes. So data word for 100. So if you are going to be used so many duplicate values, instead of initializing every duplicate value, just you have to use one directive, that is duplicate dw with the data segment. And ends, you know that ends is to end the segment. So here, and some you use the group is what? If same categories of instructions. So many group of instructions we studied in the third unit. Logical units, logical instructions we studied yesterday. Arithmetic instructions we studied. And data byte word instructions we studied. And different kind of interrupt instructions we studied. So all different kind of groups purpose particular group we have to use a group directives, group. And also we are using a label. So while giving a particular uh procedure is comes, while giving a particular name to a instructions, that time you have to use the label. And name for a particular mnemonics, particular variables, we have to use the name. And offset values also we have to use them. So 16-bit plus 4-bit, whenever that data bus is comes, address bus, it's a 20 bits, right? 16-bit plus 4-bit. that offset purpose value, we have to use the instruction pointer. Instruction pointer is nothing but what? Offset values. For that purpose, we have to use the directives. And for originating means whichever is comes from the beginning, there is no change. At the founder, first one, that purpose we are going to be ORG, originate. So after that, so group is there. Up to that, again some more directives we have to use. Proc is in the sense what? Procedure, we have to use it. And PTR is for pointer, we have to use it. PROC is a procedure, PTR is a pointer. And public, we have to use it. Public directives, whatever the data we declared with the public, that data anyone, anywhere, anyone they can access it. So to give the authority to access all the peoples, that time we have to use the public directives. So after that, segments we use. What is the segments? Different four types of segment: core segment, data segment, extra segment, and stack segment. Purpose we have to use it. And for the short is in the sense what? Very less byte, which is started, for example, 1 byte is equal to 8 bit. 1 bit is nothing but a very short. After you are not going to do the short with this. So that is a short. And type is there. Type is for what? That is convert one directive to another. For example, if you are going to convert word to byte, byte to word, word to double word, that time you have to use the type directives. So all those explanations only here, just to go through it. And public type is there. So at the end, DOS function calls are there. So these seven are specific purpose we are using in the microprocessor, because that inventors, they have to made it as constant particular values, so that int21h in every program we have to use. That is the thing about the call DOS functions, disk operating system. At the end of the output session, you are going to be use this. So this is all about your directives. I think I cleared you twice. I think I cleared you. Still any more doubts in this? Please, anyone, raise the voice. So see, what you will do, this presentation I prepared very well for your easy understand purpose, and all the explanations also I will given, with the examples also I will given for each directives. Just you go through it. You have to scan, you have to study well. Again, still any doubts on this, please you contact me, okay? So this is all about a third unit. So can I say by today third unit is completed? Okay, so entire first unit as per the syllabus. Okay, I will open the syllabus here. Please all of you check it out. So in this microprocessor syllabus, I have to cover this much portion. See, first introduction to microprocessor, first unit I have to cover. Second unit, 8086 microprocessor I have to cover. All the addressing modes, instruction execution timing we covered. And by today we have to cover third unit, assembly language programming. So actually this assembly language programming is 6 hours, but I took more than 9 hours, because this third unit is very important. All the third unit completes, it is completely only the instructions. All the instructions are comes in the third unit only. So please, I will request you, I will suggest you, I will post to you, you must and should learn all these instructions whatever we studied in the third unit. So after this today's lecture, I have to prepare all the instructions. I have to make a list of all the instructions, and I will forward to you. Instruction, meaning of instruction, instruction, meaning of instruction, like that. I have to prepare a list and I will forward to you. So please, all of you, make perfect with all these instructions, whatever we covered in the third unit. Once you perfect with all these instructions, later on it is very much easy for your lab session. Entire your lab session is containing only these instructions. Already you saw one program. All the whatever, see, in the program one, just I will revise you. In the program number, this program number, uh, Okay. See, you have to check it out. Up to now, whatever I teach you in the 3 units, is there any new things here in the first program? See, the first line is assume CS code DS data. CS is nothing but code segment, DS is data segment. I have to cover. That is assume is a directives. Today I have to cover. Next one is this is the area of the code segment. Sorry, data segments. In the data segments, I have to use two registers A and B with the sum variable. Or you say it is a directives with the DW data word directives, and I have to assign the value. Next one is I started with code segment. So here once the data segment is completed, that time I have to use ends of data. Data ends segment. Ends is end segment. This is we have to use it. Same way we have to use it for the code segment. So this is the area of code segment that start with the start. That is keyword with the start. So here move x, move instructions I explained you, and add instructions I explained you, and interrupt instructions also I explained you. Nothing is new, right? Whatever we explained in the third unit, exactly we have to use it in the lab sessions. Yes or no? Please, all of you agree or not? And also at the end, you have to end with the code segment. That is the code ends directives, and here you have to start this code segment. So at the end you have to end the start. Nothing is new, right? Whatever we studied in the theory part, same it will reflect in the lab sessions. So for that, what I am saying, if we are perfect in the unit number 3 theory part, unit number 3, all the instructions, afterwards lab session is very much easy for us, for you as well as me, once we know all the instructions. So for that, at the beginning I have to completed all the instructions. Once you perfect with this, it is very very easy for your lab sessions. So dear all students, please listen here. So this is the program for addition of two 16-bit numbers. So in the lab, we will go to the syllabus. That's the lab parts. Dear all students, am I audible and my screen is visible, right? Please reply anyone.
Yes,
Yes,
sir.
sir.
Yes, okay, fine. So dear students, this is the lab session. In the lab session, uh, first, what is the first program? First program is addition and subtraction of two 16-bit numbers. So in this first program, we have to complete an addition. Okay. So now we will go for subtraction. We will go for subtraction. So I will give you just 5 to 10 minutes. Who are installed that awesome software, you go and practice it. So dear students, this is the program is already with you. So here, this is the addition of two 16-bit number. How we have to go for subtraction? See, same first line, everything is going to be same. Only you have to change this. Instead of add, what instruction we have to use it for subtraction? Can you tell me anyone? Please, anyone, can you tell me which instruction we have to use it for subtraction? Forgot. What I explained you forgot. Okay, no.
Yes, you.
Yes, very good. SUB. Instead of ADD, we have to use SUB. SUB is for subtraction. ADDD is used for addition. So here you have to use the, instead of add, you have to use subtraction, SUB. So for that, again, for here, instead of sum, for the addition, you have to take a sum, right? For the subtraction, you have to take some other variable. Maybe you have to take a difference variable. Difference is nothing but subtraction. So instead of sum, you have to take it here, DIF. DIFF you have to take. DIFF is difference. Difference in the sense subtraction. So can you execute the program and send me the output screenshot to me? same program code, same program code. Otherwise, I will go through this. Okay. I will share with you this code for the subtraction. For the subtraction, I will share with you this code. Go and type the program in the TOSM and send me the output screen. If you send me the output screen, then only I have to say that you are completely understood first program. So, okay, come to the microprocessor group. I'll send you that code. Okay, so program number 1, that is the B section, subtraction of two 16-bit number. Go through it and send me the output screen. How we are going to be executed addition, same way we are going to be do the subtraction. So this is the subtraction code. So only you are going to be changed, instead of ADD instruction, you have to use SUB instruction, subtract instruction. Remaining everything is same. And in the sum variable, you have to declare some other name with difference. Please, I am waiting your output. At the end of this session, I'll show you the demo. I'll show you the execute this program, but I want output from you people. Try this code in the TOSM software. Fast, send me output screenshot. Yes, be fast. Output anyone? Okay. Dear students, you have to practice no problem. So I will explain you here with this TASM software. So please all of you observe. See my screen. Here I will open. Uh, See, this is the TASM software. I have to open. Okay, please all of you observed here how to execute. Because again it is the beginning step. This program you have to observe here. Later on, next onwards, you have to execute by your own. Okay. So yes, this is the command. So at the first command, I have to use edit. Name of the file I have to use yes. BBB triple B I have to use with A. Okay. So that is what is the name of the file? Yes, BBB subtraction purpose. So this is the command window. Again, how to use it here? Assume. What is assume? AWS. Assume. CS is nothing but code, and DS is nothing but
Data.
data. Yes, very good. So next line you have to declare a code segment. Code segment. So in that you have to declare any of the two variables. So here, sorry, it is data segment. So before that you have to declare the data, right? Data segment. So in that you have to use it any of the variables. Here for the A variable I have to use it directive DW with some value 3400H. Any value we have to take your convenient. For the B register, again I have to declare one of the value, that is 2500H. So next what we will going to do, we have to going to do the differentiate. So this is the variable diff, that is with the question mark, because we don't know this diff with DW. Okay. So this is the data segment. Again, once the data segment is ends, then you have to end with the data segment by data ends. Data ends. Okay. So this is the data segment. Next we will go for code segment. Code segment, here the code is start. That's what I have to use the start keyword. So in that start, again you have to use the instruction, that is move ax comma data. So here one of the student is asking the question why this. Okay, one more time. move that ds comma ax. I will explain you later. Move, just to take the program, move ax 4C00H. Next, you have to transfer the value, move AX register, you have to transfer with A register. Next, move BX register you take and transfer the B values. Next, you are going to be do the subtraction. For that, you have to use the SUB instruction, that is AX comma BX. So next, you have to transfer move to the difference, that difference variable with the AX. Okay. So after that, you have to use interrupt 3. After that, you have to end with the code. So for that, you have to use code ends, because it is a segment. Code ends, and at the last, you have to use the end start. Okay, dear students, this is the program for your subtraction of two 16-bit number. This program is for subtraction of two 16-bit number. After typing this program, what you will do? You have to save the program. You have to save the program. Go to file, save this program. So that program name already we have to take it in the edit file. So here, okay. So in the edit file already we have to save with SBB, right? So this is the program. You have to save this program and exit this. Go to command prompt. So here you have to give the link to the TOSM. How to give? That is TOSM, name of the file SBBB dot ASM. Second command. So here error message is there is 0 errors and no warnings in this. It means that our program is correct. Next we will go to t-link space name of the program or name of the file dot obj objective file. You are going to be do the link the turbo. So that is the t-link. So here again you have to press the enter. So here you have to getting a no stack warning on no stack. It means that everything is going to be fine. So that last command you have to type again td name of the file dot exe, because it is a executable file. So you have to your output window is comes here. So that program is no stable. So here you have to click on OK. Right. So here, see, go to the view window. In that you have to click on CPU. Go to the view window. In that you have to click on CPU. After that you have to go and press F7. So here I have to press the F7. You have to observe what about this. Okay. So you have to observe what about this all the registers. So here I have to press F7. So that is moving all the values. So you have to getting here. Okay, that subtraction is going to be happen. So this one thing. Trace set of F7 and help mod. Okay, I think many of you are sending the output. I'll check it all the outputs. Okay, fine. Yes, very good. Almost many of the students are sending this output. I'm very happy for that. Okay, dear students. So same way, how you are going to be executed. Uh, okay, just 1 second. I will quit it. Exit. Okay, fine. So yes, TOSM is there. Just I have directly go to the executable file. So td name of the file is sbb dot exe. This one I'm going to be execute. So here this is the view CPU. So now we are going to be press the F7. So ex is getting some memory, and next one we will move to ds. We have to transfer the value to the 4C00 is a starting memory address. Next one we have we have to dump to the first value, that is ax 3400h. Next I have to load the bx register value. Bx is 25 Next I will go to subtraction. Subtraction of ax and bx. What value we have to getting? So you have to subtract. You will get this value 0f00. So it means that that is the result of subtraction of these two variables. So I think all of you have to understood. So dear all students, by today, first programs as per your lab syllabus. First programs I have to complete it, addition and subtraction of two 16-bit number. So you go and do the practice in your home, and any doubts or any problems or any difficulties arises, please contact me. In the next lecture also, I will repeat all your doubts, and this concept again I will repeat within 10 to 15 minutes, and I will go for a second program in next in my next lecture. Okay. So dear all students, go and do the more practice, and all of you be perfect with the third module. That's why third unit, all the instructions. Once you come to know all the instructions, this microprocessor subject is very much easy for you. Once you have to very well known about all the instructions. Okay. So every day, a minimum 1 hour, you have to recall all the instructions. Only 50 to 60 instructions are there. All the instructions, I'll send you that list. Today, I'll send you that list. Every day, you have to recall minimum half an hour, 30 minutes. And this microprocessor, now onwards, it becomes very easy to you. So microprocessors, everyone is saying toughest subject, but don't keep this thing in your mind. I will say microprocessor is very easy subject. When it becomes a easy, once you come to know all these instructions, whatever we explained in the third unit. Okay, so you be perfect, uh, and we will continue with next lecture. I'll start with fourth unit. Fourth unit is very small unit, and parallelly we have to start it every one lecture, one program we will execute it. So hardly 12 programs are there. All 12 programs we have to execute as per syllabus. He is mentioned 8 to 10 programs, but we don't go for 8 to 10. All 12 programs we have to study, we have to execute, and we have to come to know. Okay. So today I have to end this lecture. All of you start to give your attendance. Type your attendance in the chat box. So please, it's my request, all of you be perfect with all the instructions. Every day, minimum 20 to 30 minutes, you have to recall all instructions. Automatically, it will become easy. That microprocessor is very easy subjects. You can't imagine now onwards how much this subject is going to be easy to you. That much easy subject. Just you have to show the interest, do the hard work, regular attendance to the lecture, and do well study. Okay. Thank you all. Thank you one and all. Please all of you attendance, and you can log out. Okay, I'm very happy. Plenty of the students are sending output. I'm very happy for that. And almost all they are sending correct output. Very good. Very nice. Yeah, please, any doubts, please ask me. Take 5 to 10 minutes and ask any doubts. Dear all students, take your own time, 5 to 10 minutes. If you have any doubts, discuss with me now also.
Hello, sir.
Yeah, please.
Sir, while talking about instructions, is
Uh-huh.
that destination operand is similar like instruction pointer? Are they similar or different?
No, I didn't get your exact question. What about if destination?
Sir, destination operand and instruction pointer, are they similar or different?
Both are different. Destination is what? It is just a one of the memory location. But instruction pointer is different. Instruction pointer is offset value. Okay.
Sir, I don't understand, sir. Sorry.
See, your question is in the destination point and the instruction pointer, both are same or different, right?
Yes.
So both are different. Both are different. Destination is what? Okay. Just I will close this. Okay. Just to observe my screen, I will quit it. I will exit this. Okay, so here, any one of the example I will take. For example, I will open that. See, for example, here in the arithmetic instructions, I'll take one example in the arithmetic instruction. Uh, See, for the subtraction and addition, so one simple example you have to take for the addition instruction. So add or add C is a mnemonics, name of the instruction. Here we have to use it one destination, and here we have to use it one source. So for to do the addition, we need two values. That's what. One value is from the source and one value is from the destination. Both source and destination we will add it, and after adding the result whatever we have to getting after adding, that one is stored in the destination. This is the meaning of destination. Finally the result is stored in the destination whenever we are using destination point. But your question, if you are used in the position of destination instruction pointer, is it your question, right?
Yes, sir.
Okay, so here you don't use the instruction pointer. Why means instruction pointer you have to use it for offset values. So in the second unit, that is segment values and offset values I explained. I think you may remember. Segment values are 16-bit. Offset values are only 4-bit, because in the address bus are that address bus and data buses are what 20 bits, right? So but our 8086 is 16-bit microprocessor. So but address bus is 20-bit. To manipulate that address bus up to 20-bit purpose, 16 plus 4 extra values we have to use. Those extra values are nothing but offset value. That offset value is nothing but instruction pointer. So for that, instruction pointer and destination totally different. You don't compare these two. Offset that instruction pointer is only used for offset values. So in any of the instruction you observed, I never used any instruction pointer IP in the any of the instructions. Are you remember that? Still, how many instructions I have to explain it? I use destination or source or both, but I didn't use it anywhere instruction pointer, because you don't use the instruction pointer in the destination. Why means Instruction pointer is only for the offset value. Whenever you are going to use address bus and data bus, that time only you have to use the instruction pointer. Even along with the instructions, you don't go and compare with IP instruction pointer. I think, am I clear your answer, your question?
Yes, sir. Yes.
Yeah, is there any more questions, please, other students? So if
Hello,
no,
sir.
yeah.
Yeah. Is it must or mandatory to use accumulator in 8086 microprocessor?
So it means that it is not a mandatory, not a must. But the thing is, by default, accumulator is there everywhere. If there is no register, by default, accumulator is there. That is must. That is compulsory. If you are going to manipulate with some other register, that time you have to use B register, C register, D register. If there is no any register, it means that in the 8086 microprocessor, by default, accumulator is there. Everything starts with accumulator. So here also you observe this screen. Here one example, that is add AL. AL is nothing but what? A register. A register is nothing but accumulator only. So if you never used any register, by default accumulator is there. It is must. Without accumulator, there is no anything. Everything is started with the accumulator only. That memory location is started with the accumulator only in the 8086 microprocessor. Is it clear?
Yes, sir.
Okay. Is there any more questions from other student? So if there is no questions, so can I stop it? But see, and one more thing, every Thursday, please all of you check the timetable. Only on Thursday in a week, timetable are changed. Every lab sessions are 1.5 hour sessions. So this is there in the timetable. Please all of you check it the timetable. As per the timetable, you have to follow the sessions. It is my request to all. So today maybe you are getting panic because you are not aware with the timetable. So timetable is there in the group, and today also I will forward you. You have to follow the timetable. Thursday only lab sessions are there. Please you have to attend 1.5 hour in the Thursday for all subjects, all lab sessions, not only this microprocessor, all lab sessions. Please carefully all of you check it out with the timetable, regular timetable. Okay, fine. Thank you one and all. We'll see you in next lecture. Thank you. Now you can log out.